fractures within that. So what happens first, if you push it like this, in this direction, first it will try to fold to accommodate the stress or the strain. Okay? And this is the stage. Sorry. You are moving very fast. I really don't like using these things. So in this stage, no earthquake develops here. No earthquake shocks develops here. In the deep interior of the earth, we have pressures because of many reasons. I will try to explain why this pressure actually accumulates at a particular place. And then, if you continue to increase the stress, at one point of time this will start slipping. But still it will have a fold, but still there is a slip. This is the stage for maximum earthquake shock emission. But eventually, the rock will try to go back to the original position after expending all its additional stress which was thrust upon that. So now it will break and displace, and individual rock will become strain-free. Now this is the stage where you have the aftershocks. That's why any area which actually got a shake, big shake, they continue to have this aftershock for months, sometimes for years. This is the stage where the rocks are actually trying to go from this part to this part. This is a cartoon, entire thing. The cartoon is just like fiction. You can do whatever you like. But truth is stranger than fiction. I will show you a picture, real life picture, what happens during earthquake. This is a picture from California. Now you see how sharp the displacement is. There was a fence. Just compare this and this. Which one is better? Surely this one is better. Just moves like this. So obviously, the first question which comes to the mind of the scientist, that are all the energies which are released because of the cracking are converted to earthquake energies? This is a very fundamental thing. I will address this question. So before I do that, let me tell you some terminologies. I mean, explain some terminologies, many of which you must have read from the newspaper. The first is the focus. This is a rock. It develops a fracture, and this is the part from where the fracture actually first started. And this is the point from which the energy actually released. The energy move, in fact, radiates from that point to all possible directions.
Sir, only from one point.
Maximum energy released from one point. Of course, there are energy released from this point, this point, this point, everywhere. But the first fracture, that is the place where the first fractures develop. I mean, fracture develops everywhere. Initially, the fractures are smaller. Only some of the fractures are successful in making big fractures. Now this point refers to the point where the big fractures first started forming. Okay. So this is focus. We call the focus, and the point vertically above this and on the top of the earth is known as epicenter. Okay. The energy radiates in all possible directions, just like sound waves. You must have seen this picture, a tuning fork. So these waves are almost similar to acoustic waves. Okay? How do you know that the sound moves like this? If I ask you that you have read in the textbook that sound moves like this. Can you prove that the sound moves like this? Can you prove it here? How?
Sir, you are speaking, sir. You are speaking. If the sound should not move in all directions, then the sound should be in straight direction. Only the person who is in that direction only can.
Great. Great.
We all are hearing.
Great. Great. Thank you very much. What's your name?
It's Nishan.
Please be seated better. Thank you so much. If somebody talks, suppose I am talking from here, everyone in the room can hear it. Because I release energy from here. It moves in all possible directions. So that's why all of you can hear me. That proves that energy releases in all possible directions. Just like the sound wave, earthquake waves also like this. Now, if from here to here, epicenter to focus, this is the shortest distance the energy takes to reach the ground. So that's why maximum devastation occurs at the epicenter. In Nepal, the epicenter was in a village called Kodari. You can Google it a bit and you can find the position of Kodari. So in the epicenter, no system can stop disaster. As you move away from the epicenter, look at these type of lines very carefully. All the energies are radiated in all possible directions. This is the shortest distance. And the next case is here. So you are away from epicenter here. And for this, you are further away. Just I have used the colors of a signal. Red signal means danger. I mean, nothing can prevent total destruction here. For yellow, well, if you are careful, you can save lives. And if it is green zone, fine. For Nepal, your state was in green zone. My state, part of it was in red zone and part of it was in yellow zone. The northern part and southern part was in green zone. Could you feel, by the way, could you feel that earthquake from here? Some of you could. Okay, but we felt it. It was terrible. I was just going out. I was almost, the moment I tried to go out of my house, suddenly started. And I surprisingly saw that the people of my locality suddenly start coming out from their houses and thronged in the street. I shouted at them, don't do this, get in. Very few people listened to me. Probably they didn't have any faith. They have more faith on the newspaper news reports. So they were just there. We felt it for more than 1 minute. It was really scary for us. Okay, but still I would say that we are in the yellow zone and you are in the green zone. Now what happens as you move away from the epicenter, since the earthquake has to travel a greater distance, two things happens. The earthquake takes longer time to reach the ground, and second is as they move through the rock, a part of their energy are absorbed by the rock. So by the time they reach the ground, most of their energy is lost and they cannot cause any major damage. So closer to the epicenter, greater will be the damage. Now coming to Nepal. This is the position of Kodari. and Kathmandu comes somewhere in between. This is the reading. This is the things which you will get on the way from USGS, United States Geological Survey. For every earthquake they monitor, they will tell you where was the focus, at what time it was hit by the earthquake, and what was its magnitude, and so on and so forth. Now, here the greatest earthquake actually was felt at the distance 29 km east southeast of Lamjung village, Nepal. Kodari was the epicenter, and Lamjung is a big place, and that's why people refer the epicenter with respect to Lamjung. Now, in the newspaper, you will always find whenever there is an earthquake, in TV, in newspaper, you will find a number. 7.9, 5.6, 6.5, so on and so forth. What does it mean? Do you know what this number means? This is the intensity of earthquake. It's a scale that measures the intensity of earthquake, and the scale you know by this time, Richter scale. So the moment this number comes, people suddenly start thinking that probably this is given in Richter scale. So before I discuss things on this, let me tell you. So this first question is still hanging. Now we will be discussing this question first, whether this number refers to Richter scale or not. Now, before I address this question, let me tell you who was Richter. Richter was an American scientist who in 1934 actually found a scale that actually calculates the magnitude of earthquake. Okay, and the scale is named after Richter. And what he did, actually, earthquake is measured by its instrument called Seismogram. It's very simple. If there were no earthquake, it would have been just a straight line. Since I said that the more dangerous waves actually shakes like this, so this pointer will also shake like this. And you have this small, big amplitude depending on the nature of the shaking. It's very simple. Then you have this curve. At this curve, the maximum amplitude, in fact, this is just like a wave. And any wave has an amplitude, and the maximum height is the amplitude. These amplitudes are expressed in microns. Okay? And then these microns are divided by a very small numbers, which we call normalization. For every amplitude, the same number is at the denominator. Okay? And then what we do, or in fact what Richter did, since you are dividing a big number with the small numbers, the result will be a big number. And then big numbers are difficult to handle, then he took a log of that. And what is the property of log? I really don't know whether you, by this time you know the properties of log. The log was invented to make the big number smaller, or look smaller. The big number is not reduced, but it will appear as small numbers. So for 100, you will get 2. For 1000, you will get 3. If the log has a base of 10. Okay? Of course, there are other form of bases, exponential, but I am not getting into that problem. So, then he took a log. And then he formed a scale. Remember that this is a log scale, so any difference from 5 to 6 means a big change. And 7.9 magnitude means it was in the major range. Okay? Then what happens now? I draw your attention to these things. Unless and until you understand this slide, the casualty of people cannot be stopped. What is this distance? This is the time. Among the 4 waves, the first one is compressional wave, P waves. So the P wave will arrive the surface fast. So that will be recorded by the seismogram fast, and we call it fast arrival of P wave. Then comes the S wave, because S wave is next to that. Then comes the L wave, R wave. They are very close to S wave in terms of velocities. Remember that P wave has a velocity of 8 km per second. So once that is released, it just moves like that in a lightning speed. Then S wave comes, it's slightly slower. Its velocity on an average to the rock is about 4 to 5 km per second. Remember that 5 km per second means 300 km per minute. 1800 km per hour. So you can imagine most of the earthquake occurs in the depth of 15 to 30 km, most of the devastating earthquakes. So remember that if the S wave, P wave moves at that speed, how much second it will take to reach to the surface? Just there is not much difference. 1800 km per hour. And you are dealing with only 25-30 kilometers. Few seconds, cracks, and then the energy comes to the surface. Now look at that. This part is known as SP interval. That is the time lag between S wave and P wave. Okay. Now from here the business is very serious, as I have explained that once the S wave starts coming, the ground will shake like this. For P wave, the ground will shake like this, not much trouble. For S wave and onward, it will shake like this or just roll like this. So once the S wave reaches, you will not get any time to flee. Now what is the difference? What is the difference? If you are very close to the epicenter, 300 kilometers, 400 kilometers within epicenter, the time is about 40 seconds maximum. This is the time you will get to run away. Just imagine our mothers and aunts with saris, or our fathers or his friends with dhotis. They are running at a speed of Usain Bolt, because if your open space is 400 kilometers away, then you have to reach that place within 40 seconds. This is the time you will get. 40 seconds means 10 seconds for 100 meters. Usain Bolt's speed is not more than that. If we were capable of running at that speed, all the gold medal would come to India. Now suppose you are in a 10-storied building, how much time you will take to come down? You cannot, just wait, you cannot. If you can, you could stay in the house. Have you seen anything, or have you seen any report where people could come out very easily and then nothing happened to him? Impossible, so don't run. And then what happens, no scare is more fearsome than the scare of life. If you know that you will be dying, and if you try to come down through stairs, you may fall. You may stuck in stump pit. Just imagine the people who are having the heart problem. Imagine the people who are suffering from diseases, cannot move. Now when I felt these things, my mother is ailing, he is in bed for last 10 years. So, I could run, in a hypothetical situation, I could run, then what would happen to her? Just imagine what would happen to the patient in the hospitals. All the children in the kindergarten? All the children in the schools? Is it possible to evacuate children within 40 seconds? No. And then, even if you can, then is another trouble. The chances that your house will collapse is far less than one of the houses in your locality collapsed that way. Many people in Nepal actually got killed not by his own house, but by the collapse of their neighboring houses. Once you come out, then where you should run? All the buildings will come tumbling. All the lampposts will fall. All the live wires, electric wires will fall on you. You are actually aggravating the risk of being killed. So don't try to run because you cannot make it. You cannot make it. If the SP difference is more than 40 seconds, if you get 5-10 minutes, only then you can come. But in that case, now I will show you, you need not evacuate your house. So actually, look at this curve. This is the point of origin of earthquake. Remember, this is in miles. So it is 1.6 times if you convert it into kilometer. So all the waves are coming like this. This is the velocity, time and distance curve. So as you are close to that, the difference between P and S waves is smaller and smaller and smaller. Now suppose you are here, nearly 1,600 kilometers away, you will get 10 minutes, but by the time the energy is so weak that you can barely feel the earth. You need not come up. But yes, sir.
Why is the difference that we will come fast?
Because its velocity is higher. Its velocity, because compression is a property of the compressional waves. It moves through the materials faster in many cases.
You said that we should not come out of the house during our...
Yeah, I will tell you what else you have to do. But I haven't told you. But I said that you don't try to come out of your house because you cannot make it. Because when the S wave hits the area, then you cannot flee. And the time, if it is a disastrous earthquake for you, God forbid, it will not happen. Then you will not get the time. Only 40 seconds, 30 seconds, sometimes 15 seconds. So before you start thinking, it will come and shake you up.
So the Richter scale ratio was the time to magnitude?
No, it's just amplitude by a small number. Amplitude in the histogram, this seismogram, not histogram, it's seismogram, there's the highest number, the length, divided by a very small number. And then it is arbitrarily fixed. Doesn't matter, every case you divide it with that number. Yes, sir.
Richter scale is not linear, so why don't we have a scale which is linear to measure the earthquake?
No. It is. This is the ratio. We are normalizing. We are not making a linear scale. It's not linear. Nowhere it is linear.
So why can't we make it linear?
No, it is not linear. It is curvilinear. It's exponential. Okay? The change is exponential because you are taking a log. Okay? Fine. So, as I mentioned, let me go back to these things. So, as you move away from the focus, the epicenter, the SP distance, SP lag, the time difference between the arrival of S wave and P wave increases. So mathematically, we can convert it into distance. If you get the time lag, you can calculate the distance of the epicenter. This is how the epicenters are calculated. So this is the thing. This is the difference between S waves and P waves, and you have a distance. So you see, if you are 40 kilometers, 400 kilometers meters, Well, I did it wrong. It should be meters. Okay, so I did it wrong. Sorry. So if you are 400 kilometers away, you will get a time about 40 seconds. So that's why I said that 10 seconds per 100 meters. Okay? So it's the velocity speed of Usain Bolt. And you know that, have you heard the name of Usain Bolt or haven't you? Okay. Even Usain Bolt could not, I don't think that he can run so fast if he had a spare of life. Okay, and you know that in an open space running at the speed and moving through all those narrow lanes. So please don't try to do this. Now, sorry, come to this slide. Now you know that intensity of any energy is almost the square of the magnitude. You know this. So actually, Richter tried to calculate that. If you calculate the amplitude, if you can rationalize the amplitude, you can calculate the intensity of the earthquake. And hey, please, better. If you calculate the amplitude, you can calculate the intensity of the energy. And since intensity of energy actually rocks the things, so it made a scale like this. Now remember one thing, as I mentioned, that the difference of 6 and 7 are terrible difference. Numerically it may appear, well, what's the difference between 6 and 7? It's a great difference because it is 31.6 times difference. Because the difference to the power that, 10 to the power that difference to the power 3 by 2. And what happens actually, one earthquake in the magnitude 8 is equal to almost 32 earthquakes having the magnitude of 7. So it's not just slight difference. It's a huge difference. Unfortunately, the numbers which this USGS and other seismologists actually quote nowadays are not the Richter scale. You get the number, but not in Richter scale. All the people in the press, they are still living in early 50s. So that number doesn't refer to Richter scale. Why? Why there was a need to change? Richter scale measures the amplitude. Amplitude gives you the intensity, but amplitude can never give you the total energy. It can give you the intensity of the energy, but not the total energy. In fact, devastation is caused by total energy, not only the intensity. Yes, intensity plays a role, but this is more appropriate. It is more appropriate that you should calculate the total energy. And this energy is known as moment magnitude. So before I define what is moment magnitude, I just show you this diagram. Suppose this is a fault. You have these fault planes. This rock has a shear modulus mu. Shear modulus means this is called modulus of rigidity. That is, if you give a shear stress, how much force it can withstand without developing a crack. That is the measure of its shear modulus. Okay. Suppose it has the material has a shear modulus mu, and this is the area of the fault planes which is affected by earthquake, and then this is the displacement along the fault plane. So once you know these things, now you can calculate the fault moment. Moment in physics, I really don't know whether you are aware of this stuff. Oh, of course you know. Moment of inertia. What is a moment in physics? Moment is any physical parameters times the distance. So work is a moment. It is force into displacement. So moment is any physical